Hello, this is Mr. Agbamu Idonnogrene. You are welcome to our lesson for today, 28th of January 2026. This is properties of plane shapes. On our target today, we are going to look at the types of plane shapes and we are going to study the properties of each of these plane shapes. So what I will do, I will list one type, then talk about the properties, and that is how we are going to do today's lesson. So let's go straight there. So the first property I'm going to look at today is rectangle. Now this rectangle, as we already know, is a plane shape that has two opposite sides that are equal and parallel. So these are the properties of rectangle. It said opposite sides are equal and parallel. All four angles are right angles. Diagonals are equal and do not bisect each other. Sorry, and do not bisect each other at 90. That means the angle at which the two diagonals meet is not 90 degrees. Take note of that. Then it has two lines of symmetry. So let me demonstrate this with our GeoGebra Classic software so that you know what we mean by that. So if you get your polygon, you have something like this. So this is your polygon. All right. So now I've drawn my rectangle. So this is a rectangle. So what this one simply means is these two sides, this side and this side, they are parallel. And if you want to show the parallel side, just click on one side of this rectangle and pull it up. You can see that the two sides they travel on a straight line. And you know the meaning of parallel lines, we say line that never meet. You can see that they travel straight. There's no way both of them will meet as long as they're traveling on this straight line. So that shows that the opposite side they are parallel. The same thing with this side. You see, it can keep traveling like this forever without meeting the other line. So this is a proof of parallel lines in rectangles have parallel lines. So take note of that. Then another thing again to show that they have equal line is that this side is equal to this side. If you count the box 1, 2, 3, 4, 5, 6, 7, 8, 9, you will see that this is 9 and this is also 9. That means the two sides are equal. If you count on this side 1, 2, 3, 4, you see that it's also equal to this side 1, 2, 3, 4. That means the two sides are equal. Then the angles in a rectangle, they are all 90 degrees, which is right angles. So if you want to understand all this, just remember the symbols. You know, in mathematics, we don't joke with symbols. So if you want to indicate parallel lines, you use double lines like this. This is what we use to indicate equal lines in mathematics. So by drawing two lines on this shape, it shows that this side is equal to this side. Then by drawing a line like this, it shows that this side is equal to this side. Then for parallel lines, we use arrowhead. So we use arrowhead to signify parallel line. So two lines are parallel in mathematics if you see an arrowhead on both lines like this facing the same direction. Then this side that are parallel, I can put arrowhead like this. I can make it double on this side so that I will not so that I will prove that this side is the one parallel to the opposite side. So something like this, it shows that these two they are parallel, then this opposite side are parallel. So that is that. Now, if I want to show the 90 degrees, 90 degrees is here. You put your symbol of 90. This is the symbol we use to indicate 90 degrees, something like this. So this is the symbol for 90 degrees, something like this, something like this. So by putting something like this, it shows that all the four angles are 90 degrees. So take note of that. So I can actually indicate the, let me delete this. You can actually use the app to show your angles. Just click on the angles you are looking for. I don't need this side. Let's start from here. Something like this. You can see the 90 degrees. The system has it for me. Tell you that a rectangle have 90 degrees. So this is how you indicate the positions of parallel lines, equal lines in a rectangle. So let's undo everything and move on. So the other property that talks about lines of symmetry, how do you show that in your paper? You know, line of symmetry, we said they are lines that divide a plane shapes into two equal parts and such that one side is a mirror of another side. So if I put a rectangle, this is a rectangle, you can see a rectangle here, and this is the line that divide it into two. So this side is telling us the two-part division, while this side is showing us the folding. If you fold one part, it will be a mirror of the other part. So as I'm turning this point, it's cutting it into two equal parts and it's folding it here. So you can see that this side, this is the line of symmetry because this part of this rectangle is mirrored to this side. So this side is equal to this side. And when you fold it, it covers it well. That means this is a line of symmetry. But if you go to a diagonal like this is a diagonal. You will see that this diagonal, it divides the line into two equal parts, but it's not a mirror because when you fold this down, cover on this top like this, you will see that these two edges did not meet, like these 2 points did not meet. So it's not a line of symmetry. So with this applet, you can monitor line of symmetry. You can see the next line of symmetry. You see the line divide the shape into two equal parts, and when you fold it, it laps very well. That is, this part is a mirror of this part. So with this, you can say this is a line of symmetry. So a rectangle only have two lines of symmetry, which is one and this other side two. These are the two lines of symmetry. So all this explanation, I'll make a diagram of this and put it in our notes and attach it to the Google Classroom. Just take note of all this explanation. It's very, very important. All right, let's finish the one we are doing now. Let's go to the next property. Let's close this. So the next property is a square. So a square, we say all opposite sides are equal and parallel, just like rectangle. All four angles are also right angles. That means all angles are 90 degrees. Then diagonals are equal and bisect each other at 90. Then it has four lines of symmetry. So the same thing here, if I come to this place, if I look for a square, let me find a square. Okay, this is a square. You can see that this square, if I cut it on this side, this is a line of symmetry because when you fold it, this side is a mirror of this side. When you cut it through the center like this, you can see that when you fold it now, this side is a mirror of this other part, which is what this one is showing. So this is a line of symmetry. If you keep going, if you cut it in this other diagonal, you will see that this part is a mirror of the other part. Then if you continue now, if you cut it again and fold it, you will see that this part is a mirror of this part. So these are the four lines of symmetry. So the two diagonals, which is 1, and this other diagonal, which is 2, then the middle lines, which is 3, and this other line, which is 4. So these are the four lines of symmetry in a square. So take note of these properties. Then every other properties remain the same as that of a rectangle. If I pull this one, let me click on it. If I pull this one to this place, such that this is 1, 2, 3, 4, 1, 2, 3, 4. You can see that both sides have 4, 4. That means they are all equal. So this is the property of a square. The four sides are all equal. And if you want to indicate this on your paper, remember we use straight line like this. This straight line shows that the four sides are equal. So this is how we represent it on paper. And they are also parallel. You can put your arrowhead to show that they are parallel. They are all parallel. Then you need to put double on this side because it is opposite sides that are parallel, not the four sides are not parallel. Then this is just a single arrow. Then this is also a right angle, and this is symbol for right angle, that is 90 degrees. This is symbol for right angle, 90 degrees. All these angles are right angles. So take note of this. So these are the properties of a square. Take note of this. Let me undo all those things I added so that we go to the next properties. All right, as we move on, let me minimize. Okay, as we move on, the next property we are looking at is parallelogram. So parallelogram have opposite sides are equal and parallel. The opposite angles are equal. Then the angles are not 90. So the angles in the parallelograms are not 90 degrees. They are not like rectangle and square that they are all 90. And you will see why it's like that. Let me show you how parallelogram looks like. In parallelogram, let's go to the applet. In parallelogram, you must first of all have a rectangle. So this is my rectangle. So instead of me pulling the rectangle up like this or down, in parallelogram, just slide it at an angle. Slide it like this. See what I'm doing now? By pulling it with your mouse to one corner, this is a parallelogram. So this is also opposite because parallelogram came from a rectangle. Just slant the top of a rectangle, just take it to one side. You see that parallelogram will form itself. So the same property similar to that of a rectangle. This side are parallel, this opposite side are parallel. Because it's actually a kind of a special rectangle that is being slanted. The two vertical legs are bent at an angle. Then this one is parallel to this one. You know, this one will signify parallel line. Use arrowhead. Arrowhead shows that they are parallel. So these are parallel line. Then it's also equal. This side is equal to this side. Then this side is equal to this side. So this single lines like this shows equal, while arrowhead shows parallel line. Then another beauty of parallelogram is we say this angle here, let me put the angle. This angle is not 90. You can see this one I just did is giving me 59.04. You can see it. So it's not 90 degrees. It will only be 90 if I pull it to become a rectangle. See, I'm pulling it back to be a rectangle. Now it's a rectangle is 90. But when I pull it straight to form parallelogram, so this is parallelogram. Now there is a parallelogram, you see the angle have changed from 90 to 60 something. And you can keep pulling it. So this is parallelogram. So you can go to any extent, depending on what you are doing. You can go to any extent, depending on how the question comes. So this is parallelogram. Take note of this. So let's delete all these lines and continue our demonstration. All right, let me be fast with this deletion. Okay, now if we continue, let's go back to our slide. So the next one is a kite. So how do you form a kite? I will explain it as we move on. So a kite has two pairs of adjacent sides that are equal. So adjacent side of kite are equal. I will show you what I mean by adjacent as I show you the shape. So one pair of opposite angles are equal. Then it has one line of symmetry. Remember, parallelogram does not have line of symmetry. You can also demonstrate it here. Parallelogram does not have line of symmetry. Let me show us parallelogram in this place. So this is a parallelogram. It does not have a line of symmetry. So if you cut it, just watch as I turn this round, you will not meet any line that you will fold and give you any line of symmetry. See, this cut it into two equal parts, but when you fold it, it did not lap very well. So it's not a line of symmetry. You see, this one also cut it into two equal parts, but it did not lap very well. So this is not a line of symmetry. So parallelogram does not have a line of symmetry. So you have zero line of symmetry. Take note of this. Then for kites, we say one pair of opposite angles are equal, then it has one line of symmetry. So the angles between the unequal side, that's the angles that are equal. The angles between the unequal sides. So let me show you what I mean by this in this applet. So coming back to this, if I pull this one back to form my rectangle, so this is a rectangle, then if I pull it to form a square, so this is a square, this is 4 by 4. Now, how do I form a kite? Just pull one of these edges, just slide it like this. So this is a kite. You can say this is a kite. So this is what we mean by adjacent sides. See these two sides that are long like this. See these two sides are adjacent. So these are the two sides that are equal. Let me use pen to signify it. So these are the adjacent sides that are equal. So this side is equal to this side. You can see it. Then this side is equal to this side. So this is the adjacent side. These two sides are adjacent to each other. These two sides are adjacent to each other. So this is how a kite looks like. I can pull this one also. It's also a kite as long as this side is equal to this side. This side is equal to this side. So this is how a kite looks like. So this is a kite, and these two angles, these opposite angles, they are equal. But these ones, they are not equal. So these opposite angles are equal. And you only have one line of symmetry, which is this line that forms the diagonal. So this line that comes from here down to this place. So this is the only line of symmetry, because if you fold this to the other side, it will lap very well and it will give you a line of symmetry. So this is a kite. You can see how the shape looks like. So just take note of that. So that is that. Let's take it back. Let me delete all these lines I did. So let's take it back. So let's put this one like this. Let's put it here. You can play with this when you get home. I'm sending you this link. So now this is a square. You can see it's now 90. So just pull one end of a square. A kite has been formed. That is just what we are doing. Just pull one end straight like this. A kite has been formed. So that is how kite is being formed. Let's go to the next one. The next one after kite is rhombus. So rhombus, we say all the four sides are equal. In rhombus, all four sides are equal. Opposite sides are parallel. Opposite angles are equal. It has two lines of symmetry. So rhombus has two lines of symmetry. So let me demonstrate this. So for rhombus, this is a square. If you want to show rhombus in this square, just pull these two ends like this, pull this like this, pull this like this. So this is a rhombus. It's a kind of a square that is being slanted. You can see that from square, I just slant it a little. So it forms a rhombus. So all the four sides, they are equal. So in rhombus, all these sides, they are all equal. All these sides, they are all equal. So then we said opposite angles are equal. If I measure the opposite angle, which is this one, and this, you will see that it will give me the same result. So you can see they are all equal. This is 112, this is 112. They are both equal. The same thing with this angle, these opposite angles, they are all equal. So this is a rhombus. You can also pull it to any other direction. I can pull it through this direction like this. I can take it like this. I can take it like this. So this is a rhombus. The four sides are equal. I can even pull it further away, then increase this one too. So this is a rhombus. The four sides are equal and the opposite angle. You can see that the opposite angle always the same. But if I pull this one back like this, see this is a kite. See these opposite angles are no more equal. But if I pull it like this, you see that they are both equal. So take note of this rhombus. Okay, the next one is triangle. We already know triangle now. You have all sides, straight lines, and there are three sides. Three sides, three angles. Then the sum of angles in the triangle is always 180 degrees. So this is a general properties of a triangle. Then we have other types of triangles like the equilateral triangle. All three sides are equal. All three angles are equal. It has three lines of symmetry. So equilateral triangles, let me use this one to demonstrate equilateral triangle. Let me use this multi-doc software to demonstrate it. So equilateral triangle, let me just get it here. You will see equilateral. See? So you can see it. It's a triangle that have all the three sides equal. You can see that all these three sides are equal. This equilateral triangle. So this equilateral triangle, all the three sides are equal. 1, 2, 3, they are all equal. Then all the angles inside there, they are 60 degrees. If I put the angle, you will see it. All the angles are 60, 60, 60. This equilateral triangle. And the three sides, they are all equal. 1, 2, 3, they are all equal. So take note of equilateral triangle. The next triangle is isosceles. Let me also use this to demonstrate this. In isosceles, two sides are equal. You can see isosceles here. In isosceles, only two sides are equal. Only two sides are equal. So this isosceles. In isosceles, only two sides are equal. Then all these angles that face each other, that's opposite angles here, they are equal. Let me just put the angle so that you see it. So this angle is equal to this angle. See 73, 73. That's one property of isosceles triangle. Very important triangle in mathematics. So no matter how big I made it to be, these two angles are equal. 67, 67. That is one thing about isosceles triangle. You can see two sides are equal. The angles opposite the equal side are equal. Then has one line of symmetry. Very, very important. The next one is scalene. So scalene is when no side is equal, no angle is equal, and it has zero line of symmetry. The right angle triangle is a triangle that has one of the angle 90 degrees. Then the side opposite the right angle is the longest, and that is called hypotenuse. Then finally, it can be isosceles, it can be a scalene, that is a right angle triangle. Then the last property is trapezium. So trapezium is gotten from a triangle, something like this. Like this triangle, for example, if I remove the top of a triangle, a trapezium is being formed. Trapezium is formed when the head of a triangle is being removed. Something like this, if I draw a straight line like this, such that this straight line is parallel to this line, and I do something like this, let me show you trapezium here. So this trapezium, something like this, something like this. So this is a trapezium. So if I remove this top, let me shade this top. If I remove this top that is red, something like this, let me click on this and pull it out. See, I'm pulling it out gradually, but let me be fast. If you pull it out like this, you see, this one that is being pulled out of a triangle, when you cut the head of a triangle, this is what we call a trapezium. A triangle that the head is being removed and such that this line must be parallel to the base. So that is what we call a trapezium. So let me just give you a sketch of a trapezium here so that you see how it is before we end today's class. So you can see it. So this is a trapezium. This side is parallel to this side. It can be something like this. It can be something like this. So this is a trapezium. So that is that. So with this, we are through with the properties of plane shapes. I will send this note. The note I will send to us, I'll put all the diagram I described in the classroom so that as you are reading it in your Google Classroom, you will understand the shapes together with their properties. I'll make them little by little on this slide so that when you open the slide, it will be clearer for you to understand. So these are all the properties I want us to learn in class. Just copy them into your notebook, study them, and the next class, starting from on Friday by God's grace, do calculation on perimeter and areas. So that is all for today's lesson. Thank you for watching. Do have a nice day.